Hello, my name is Paris Desjardins, and today I'm going to be talking about the crucial role of speech language pathologists in math intervention. As an SLP student, this is certainly not an area I thought that we could support both students and teachers in. And I'm sure that the majority of people, including parents and teachers, would never think of asking an SLP to help with their struggling math learners. This presentation not only serves as an educational piece, but also aims to advocate for the pivotal role of SLPs in enhancing math learning. Today, I'll be going over the connection between math and language, which looks at why language is so important in math. I'll be looking at different linguistic barriers that can occur in mathematical learning. And finally, I'll be going over how SLPs can enhance teacher-student support and offering a few tips for both SLPs and teachers alike. I'm sure that most of you have heard that math is a universal language. This is because math uses symbols and numbers that are the same across all languages. However, when you really think about it, math is far from being a universal language because it requires reading and language skills in order to actually understand math. These concepts are taught in different ways using different languages, which brings me to my next point that math is like learning a second language. In order to successfully talk about math, which is expected of students, it is important to learn the appropriate language. New vocabulary is introduced with every new concept being taught. To give you an idea of just how many words children need to be familiar with in order to be successful in math, there are over 400 math terms in grade 7 textbooks. This number does not include general vocabulary or vocabulary that have various meanings, such as a cube, for example, which is a shape and also means to multiply a number by itself 3 times. So you can imagine how big this list of vocabulary really is, and it only increases once students reach high school. Language also plays a significant role in terms of math assessments. The higher the grade, the more word problems are used. In fact, most provincial, national, and international math tests predominantly use word problems. For example, in an international test called the Trends in International Mathematics and Science Study, which is given to fourth graders in the US to compare math skills to other countries, it was found that each question had an average of 23 words. The average of numbers and symbols used in the questions was only 5. So children not only need to know math equations, but they need to be able to read and understand on average 23 words per question before they can even begin to work on the math problem. And this is common in most math assessments. Finally, math and reading skills are predictive of each other. Kids who do well in reading tend to do well in math and vice versa. Furthermore, academic language is a strong predictor of academic success. To become proficient in academic language and math, there needs to be oral and written exposure, as well as oral and written production within this area. However, many teachers ignore this crucial step in math learning. When it comes to math specifically in Canada, a study called the Program for International Students Assessment recently released its results and found Canada to be in the top 10 in mathematics proficiency out of 81 jurisdictions worldwide. Ontario was number 4 out of the Canadian provinces. This is great news. However, what the Canadian government does not advertise is that the Canadian math scores have actually been steadily declining for the last 20 years. This decline is being seen all over the world. This is concerning considering math is an increasingly needed skill in a rapidly increasing technological world. On top of that, 1 in 5 students performed at the lowest level of math. This makes up 20% of students. It goes to show that now, more than ever, students need better strategies for learning math. Although SLPs work with students with a large variety of difficulties, some students may be more at risk of having math difficulties than others. Developmental language disorder is a disorder where language abilities are impaired. Those with DLD may have trouble with encoding, retrieval, and consolidation. This disorder is seen in about 7% of children. In a longitudinal study, the language skills of children with DLD at 7 years old were found to be indicative of their later mathematics performance as reported by their teachers at 11 years old. Other studies have found that children with DLD obtain lower scores on curriculum assessments of math compared to the national averages. Clearly, there is a strong association between language impairment and math skills. In one study by Cross et al., it was found that children with DLD consistently perform lower on number transcoding, counting, arithmetic, and story problem tasks. These tasks have high verbal demands, so finding strategies to decrease these demands while improving retention of math vocabulary would be beneficial for this population. Ontario is one of the most multicultural provinces in the world, which means that most teachers and SLPs will have various students who are English language learners. In fact, the number of English language learners is steadily increasing. Math can be challenging for this population because not only are they learning math, but they need to learn math vocabulary and concepts in their second language. This, along with processing complex sentences, increases cognitive demand. If English language learners have difficulty learning adequate levels of math, then they will have many challenges moving on to more complex mathematics, which creates academic achievement gaps that are difficult to close. In the US, 42% of English learner fourth graders have below average math skills. This percentage increases to 72% by grade 8. One study tested English language learners whose native language was Spanish. When tested in English, they scored significantly lower than their monolingual peers. However, when given the same standardized test in Spanish, these students performed as well as their peers. The problem then is not that multilinguals have trouble with math, but more so the language related to math. Another common disability is learning disabilities. There can be specific learning disabilities, such as one specific to math, for example, or more general learning disabilities. Regardless of whether it is specific or general, children with learning disabilities tend to struggle with the language and literacy aspects of math. In particular, they have difficulties with more comprehensive tasks, such as word problems. Children with specific math learning disabilities might have further difficulties with counting, number combinations, computation, and solving word problems. Once again, this highlights the importance of language intervention in the field of math. So, how can an SLP help? Well, SLPs can conduct assessments to identify language or communication difficulties that may be impacting math learning. They can develop individualized intervention plans to address specific math-related language issues. SLPs can assist in developing problem-solving strategies. They can teach students how to break down math problems into smaller, more manageable parts, improving both comprehension and execution. They can identify language barriers that may hinder a student's ability to understand math concepts, instructions, or word problems. SLPs can teach math vocabulary using evidence-based approaches. They can work on executive function skills that are crucial for math success, such as organization, planning, and working memory. SLPs can also work collaboratively with teachers and other staff in the school system to promote math learning in the classroom by giving strategies to improve various skills. Next, I'll be providing some strategies to help SLPs and/or teachers when looking to increase knowledge of math language in struggling math learners. When thinking about the various vocabulary used in math, it is important to think of them in categories because this will help you decide the best way to teach the terms and which terms needs more focus than others. There are 4 categories of math vocabulary. The first is technical vocabulary, which are words that have one meaning, and that meaning is specific to math. For example, words like numerator, denominator, and reciprocal are technical words. The second category is sub-technical. These words have more than one meaning, one of which relates to math. For example, words like round and regroup are sub-technical words. The third category is general vocabulary, which consists of words used in everyday language that is also used in math. So words like more, longest, shortest, etc. Finally, the fourth category is symbolic vocabulary. These words are used to explain numbers and symbols. So for example, words like 0 or equal. Now, imagine that you have a student with DLD. His teacher uses the terms reflections, rotations, and translations consistently in class to describe transformations. These are all formal math terms. But then, when the educational assistant works with him, she uses the terms flips, sides, and turns. These are all informal terms, but mean the same thing. You can imagine how someone with DLD, or any student for that matter, can get confused when different terms are used by different people. Although using informal language can help students learn math vocabulary in the first few years of math learning, it becomes increasingly important to use formal terms as math becomes more complex and as more and more vocabulary is introduced. Students with DLD, learning disabilities, and English language learners need regular exposure to formal math terms. In fact, all students need this exposure. The majority of math terms are used only in the context of math class. So if children are being exposed to both informal and formal vocabulary during this time, then it creates less exposure to the correct terms. Some math terms also have very similar characteristics, which many will wrongfully use interchangeably. It is important for teachers to explicitly teach the differences in these words. Math also uses words that have various meanings. For example, look at the word square. A square is a shape, but it also refers to multiplying a factor by itself. Students may also call someone square, meaning that person is boring. There are multiple other meanings for the word square, so it is important for students to be able to differentiate between all of them. It is especially important to use formal language because formal terms are standardized and correct. Additionally, most assessments used in higher grades use formal math terms. In a paper by Powell et al., there are various figures that give examples of language educators should use. The figure is shown here to the right. Feel free to pause the video to take a closer look. Another figure by Powell et al. Shows examples of terms that need teachers to be precise about because oftentimes some terms are incorrectly used interchangeably. For example, look at the word factor. You may have heard this word used interchangeably with the word multiple. However, this is incorrect. The word factor describes all of the whole numbers by which you can divide a number with no remainder. So for example, the factors of 8 are 1, 2, 4, and 8. The term multiple refers to the product after multiplying 8 by another whole number. So for example, 8, 16, and 24 are multiples of 8. Once again, this shows the importance of carefully choosing language when teaching math. Another great example of this would be teaching fractions. Most of us have learned that fractions consist of the numerator and the denominator. If the teacher were to describe fractions using the phrases top number and bottom number, this can give the illusion that fractions are made up of two numbers, when in reality, it consists of one number. The language can affect how students view math problems. Teachers have a lot of content to cover, so focusing on explicitly teaching all of the vocabulary is challenging. Jennifer Bay Williams and Stephanie Livers offer some strategies for choosing when to focus your time on vocabulary. When it comes to context, ask yourself these questions. Is the context culturally relevant? When students can relate to the topic and find it interesting, then they're more likely to engage more actively. Is the context familiar or new? If it is new, then consider the importance of learning that context. Will the context ever be used again? How much of the context needs to be learned in order for the students to understand? Finally, can the context be reused? If the context is being used in another course, then it is a great opportunity to continue development in various context areas. It is also a great way of exposing students to vocabulary used in multiple contexts. If the teacher decides the context is new and is appropriate to keep, then a vocabulary preview should be implemented at the start of the lesson. Next, it is important to ask yourself if the mathematics vocabulary is new. If so, then explicit teaching of the vocabulary is necessary. Consider if the vocabulary has multiple meanings. If so, it might be useful to go over the different meanings. Finally, Is the mathematics vocabulary a review? If so, it might be best to review already learned concepts at the beginning of the day. This should only take a few minutes and can be done through answering a question of the day or a morning message, maybe homework prompts or read alouds. Those are just a few examples. Thank you so much for listening to my presentation. Here is a list of my references. Please feel free to look at the papers as they are really great resources.